All right, so I'm going to move on to another one of the new formulas for Leaving Cert that are not on the Junior Cert course. And it is a formula to get the perpendicular distance from a point to a line. All right, so this is on the top of page 19 in the log table. So most of these line ones are on page 18. And there's a couple of them then on the top of page 19. This is one of those. So distance from x1, y1. So distance from a point to the line ax plus by plus c equals 0. And there's your formula. That form the line is in is significant. Okay, but just I'll go into an example and we'll use the formula then. So find the perpendicular distance from the point 4 minus 1 to the line 3x minus 4y equals 7. So line roughly looks like this. All right, there's 4 minus 1 over there, and you are getting the perpendicular distance from that point to that line. Okay, so the distance that will form a perpendicular with it. Okay, so that at a 90 degree there. So you could also refer to it as the shortest distance from this point to this line, because the shortest distance will meet it at a 90 degree angle as well. It's directly from this point to this line. Okay, so it's this distance here that I'm getting. All right, just in that small little diagram there. So let's write my formula. So my formula for perpendicular distance, which is P for perpendicular distance, is equal to the absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared. All right, and then over here tells me what a, b, c, and x1, y1 are. All right, now just one thing about this formula. From the point to the line ax plus by plus c equals 0. So that's the standard form of the line. You see, everything is on one side equal to 0, and your line needs to be in that form before you start using the formula. So if you look at this line here, 3x minus 4y equals 7, I need to move the 7 over to the left hand side. So everything needs to be on one side equal to 0. So I'm just going to change this so that it is 3x minus 4y minus 7 equals 0. All right. So now your a that goes into the formula is whatever's in front of the x. So my a is 3. Your b is whatever's in front of the y. So my b is minus 4. Don't forget to take the sign in. And the c is minus 7. All right, so there's the a, b, and c that are going to go into the formula. The x1, y1 then are just the point. All right, so I'm going to plug those in. You can see the formula here has absolute value signs on top and then two numbers squared and added together on the bottom. So it's going to give us a positive number on top and a positive number on the bottom. Distance has to be positive, all right? So this is equal to the absolute value of a. So that's the number in front of the x. So that's kind of here is where you get your a, b, and c. A, b, and c. So it's the absolute value of 3 times x1 is 4 plus b. So b is minus 4 times y1 is minus 1 plus c is minus 7. All over the square root of a squared plus b squared. So that is 3 squared plus minus 4 squared. Yeah. All right, so let's just work top and bottom out. So on the top, I've got absolute value of 3 times 4 is 12. Minus 4 times minus 1 is plus 1. Plus minus 7 is minus 7, all over the square root of, so 9 plus minus 4 squared is 16. So it's equal to the absolute value of 12 plus 1 is 13. 13 take away, oh no, so I meant to say, so sorry, minus 4 times minus 1 is plus 4 here, sorry. So yeah, sorry. So 12 plus 4 is 16, minus 7 is 9. So it's the absolute value of 9 over the square root of 25. The absolute value of 9 is just 9. So if you get a negative number here, absolute value signs just turn it into a positive. So it is equal to 9 over the square root of 25 is 5. So there's your perpendicular distance between that point and that line, 9 over 5. All right. So I'm just going to do another example over here, which is going to turn into one of these questions, but it's just a little something I need to do first. So find the distance between the parallel lines x plus 2y equals 4 and x plus 2y equals minus 7. Even if they didn't tell me they're parallel lines, I would be able to tell from the format, okay, x plus 2y. So that if the x and the y bit are identical, then you've got parallel lines, okay? They're equal to different constants then. So basically the situation you've got here is two parallel lines. If you get any point on this line and then get the perpendicular distance from that point to this line, you are getting the perpendicular distance between the two lines. Okay, so because they're parallel, the perpendicular distance between them is constant. It's always the same. So if you get any point on this line and get the perpendicular distance from that point to this line, you are getting the perpendicular distance between these two lines. Or if you get a point on this line and get the perpendicular distance to this line, then from that point, you're getting the same thing. Okay, so it doesn't matter which line you pick. So just pick one of the lines to get a point on, and then get the perpendicular distance from that point to the other line. And that is the perpendicular distance between the two lines because they are parallel. Okay, so only when they are parallel will this be the case, because between parallel lines, the perpendicular distance is constant. If they're not parallel, it will change. So if I pick this one here to get the point on, and I will sub 0 in for x. So when x is equal to 0, then I've got 0 plus 2y equals 4. So 2y equals 4. So y is equal to 2. So my point on that line is 0, 2. All right, so this is the point I'll use. So then the other line I'll use was this one. So this is going to be my x1, y1. This line here, before I use the formula, remember it needs to be in standard form. So I need to move that minus 7. It needs to be everything on one side equal to 0. So x plus 2y plus 7 equals 0. So my a is whatever is in front of the x. So here it is 1. So a is equal to 1. B is what's in front of the y. So b is equal to 2. And c is the constant at the end. So c is equal to 7. So let's write down my formula then. So again, top of page 19 is where you'll find it. So perpendicular distance is absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared. So this is equal to a is 1 times x1 is 0 plus by, so that's 2 times 2 plus c is 7 all over square root a squared, so that'll be 1 squared plus b squared, so plus 2 squared. So this is equal to absolute value. 1 times 0 is 0. 2 times 2 is 4. 4 plus 7 is 11. So it's the absolute value of 11 over 1 squared plus 2 squared. So 1 squared is 1, 2 squared is 4. So square root of 1 plus 4. So it's equal to, the absolute value of 11 is 11 over 1 plus 4. So the square root of 5. So the perpendicular distance is 11 over root 5. If you got something like that, just pay attention to the question, what form they want the answer in. They might want you to leave it like that, or they might say correct with a certain number of decimal places. So 11 divided by root 5 is around about, let's say if they said 1 decimal place, that would be equal to 4.9 units. But just pay attention to the form they want the answer in. All right, so that's the perpendicular distance formula used to get the distance between a point and a line, and over here used to get the distance between two parallel lines.